Discuss the convergence of integration 0 to infinity x by 1 plus x whole cubed dx. Here I equal to integration 0 to infinity x by 1 plus x whole cubed dx. Here the upper limit is infinity. Now I am changing this upper limit as t by writing limit t tends to infinity integration 0 to t x by 1 plus x whole cubed dx. Here observe the denominator. Denominator is 1 plus x. That's why I am replacing numerator as 1 plus x minus 1. Cancel this plus 1 and minus 1, then we are going to get x only. Now the form of the numerator is changing, but the value is not changing. So x can be written as 1 plus x minus 1. Denominator as it is. Here you can observe 1 plus x minus 1 by 1 plus x whole cubed we have. I am taking this as a, this as b, this as c. We know that a plus b by c can be written as a by c plus b by c. So here you can observe 1 plus x by 1 plus x whole cubed dx minus 1 by 1 plus x whole cubed dx. Here observe 1 plus x, 1 plus x cancel with 1 plus x. Then we are going to get 1 by 1 plus x whole square dx. This integration as it is. Now here the power of 1 plus x is having power as 2. This term goes to numerator. Then we are going to get 1 plus x whole power minus 2. So we 1 by 1 plus x whole cubed can be written as 1 plus x whole power minus 3. We know the formulas for power. That is integration of x power n dx is x power n plus 1 by n plus 1. Here apply this formula. Then we are going to get 1 plus x power. For this term n is minus 2. Minus 2 plus 1 by minus 2 plus 1. Limits are 0 to t. For this term n equal to minus 3. 1 plus x power minus 3 plus 1 by minus 3 plus 1. The limits are 0 to t. We know minus 2 plus 1 is minus 1. Minus 3 plus 1 is minus 2. So the integration finally completed and also simplified. Now we are going to substitute limits. So observe, this is negative term. This term I am writing here. Minus into minus is positive. The limits are 0 to t. So next I am going to substitute upper limit first in the place of x. Then 1 plus t power minus 2 by 2 minus 1 plus x 1 plus t power minus 1. So for this term upper limit is substituted minus. Now I am substituting lower limit 0 in the place of x. Then 1 plus x power minus 2 by 2 minus as it is 1 plus 0 power minus 1. So here the power of 1 plus t is minus 2. This can be written as 1 by 1 plus t whole square. Negative power becomes positive when it goes to denominator. Negative power goes to positive when we write 1 plus t in the denominator. 1 plus 0 is 1 only. 1 power anything is 1 by 2 as it is minus 1 power minus 1 is 1 only. Next I am going to substituting t tends to infinity. Replace t with infinity. Here then 1 plus t becomes 1 plus infinity. 1 plus t becomes 1 plus infinity. 1 plus infinity we know that it is infinity only. Infinity square is infinity. Infinity into 2 is infinity only. So the simplification of first term is 1 by infinity. The simplification of second term also 1 by infinity. But we know that 1 by infinity is 0. 0 minus 0 is 0 plus 1 by 2. 0 plus 1 by 2 is 1 by 2. Here I am getting 1 by 2. This 1 by 2 is finite and unique. Therefore, the given integration convergent and its value is 1 by 2. Next question, evaluate integration 1 to infinity dx by 1 plus x into root x. So, take I equal to integration 1 to infinity dx by 1 plus x into root x. Here I am taking, here we have upper limit is infinity. I am writing this upper limit as t by taking limit. Limit t tends to infinity, integration 1 to t dx by 1 plus x into root x. Take root x equal to z. Differentiate. We know that differentiation of root x is 1 by 2 root x. Dx as it is, dx we can write, z differentiation is dz. Next, this division 2 goes to RHS as 2z. 1 by root x into dx equal to 2 into dz. Whenever substitution takes place, limits must change. When x equal to 1, that is lower limit of this integration is 1. Substitute 1 here, root 1 equal to z. That means z equal to 1. The upper limit of x is t. The upper limit of this integration is t. X equal to t. Substitute root t equal to z. That means z equal to root t. So the new limits are 1 to root t. Substitute new limits and convert total integration into z. So observe, we have 1 by root x dx. Write down that as 2 into dz. 1 plus x as 1 plus. Here you can observe root x is z implies z square equal to x. So replace x with z square. So to keep aside, integration of 1 by 1 plus z square is tan inverse of z. The limits are 1 to root t. 2 is constant, put outside. Limit t tends to infinity. Tan inverse of upper limit minus tan inverse of lower limit. Now I am substituting t equal to infinity. 2 as it is tan inverse of root infinity minus tan inverse of 1. Root infinity value is infinity. This term tan inverse of 1 as it is. Infinity can be written as tan pi by 2. 1 can be written as tan pi by 4. Tan inverse tan, the simplification of this term is pi by 2. The simplification of this term is pi by 4. Pi by 2 minus pi by 4 simplification is pi by 4. 2 1s are 2 2s are. Then we are going to get pi by 2, which is finite and unique. Therefore, the integration 1 to infinity dx by 1 plus x into root x is convergent, because here we are getting finite and unique value, and its value is pi by 2.